Welcome to all my students in the radio Pathshala class. Today I am going to start the area of triangle and quadrilateral. The area of triangle and quadrilateral. We have already learned how to find the area of triangle, rectangle, square, rhombus, parallelograms. Now I am going to review the area of these geometrical figures. First of all, triangle. This is a triangle ABC. In this triangle, suppose a perpendicular is drawn from the vertex A to the base BC. AP perpendicular is drawn from the vertex A to the base BC. Then AP of triangle ABC, this AP line is called the height of this triangle. It is denoted by H. It is the height of triangle ABC and BC is the base. This is the base. The side on which we draw the perpendicular is called the base. Here we have drawn AP perpendicular to the base BC. So BC is the base. Let's look another triangle. In this triangle, ABC triangle, if BQ perpendicular is drawn on the side AC, then BQ is the height. BQ is the height, and in this case, AC becomes the base of this triangle. We suppose AC is the base. Now, if we have height and base of a triangle, then the area of triangle is area of a triangle A equals to 1 by 2 base into height. To calculate the area of a triangle, we use this formula. Area of a triangle A equals to 1 by 2 base into height. In some figures, it is given this is the perpendicular. ABC is a triangle and CR is perpendicular to this line AR. In this case, it is the height of triangle ABC. It is the height of triangle ABC and BC is the base because it is also perpendicular. And in this case, BC should be parallel to AR. BC and AR are parallel, then RC is perpendicular on BC or it is perpendicular to AR. So RC is height of triangle ABC and BC is the base. So area of triangle ABC equals to 1 by 2 base BC into height RC. In this way, we find the area of triangle. Next, rectangle. 2 number rectangle. Rectangle. We are familiar with rectangle. This is a rectangle. We know the opposite sides of a rectangle are equal, and at least one of its angle is right angle. It is the length and it is the breadth. In the rectangle ABCD, this AB is the length of rectangle and BC is the breadth of this rectangle. And its area of rectangle, area of a rectangle A equals to L into B, length into breadth. In this way, we find the area of a rectangle. Next, 3 number square. Square. Square is a parallelogram in which its all sides are equal and at least one of its angle is right angle. This is a square. In the square, all sides are equal, so we can suppose its sides by L. AB is L and BC is also L and CD is L and this is L. So area of a square, area of a square A equals to L square or side square, length of a side square. Next, parallelogram. Rectangle, square are also the parallelograms. Now, three number parallelograms. Parallelogram. A quadrilateral in which the opposite sides are parallel is called parallelogram. This ABCD is a parallelogram. Its opposite sides are parallel. If it has opposite sides parallel, then it is called parallelogram. Area of a parallelogram, area of a parallelogram area of a parallelogram A equals to base into height. Base into height. Base into height. Suppose this AP perpendicular is drawn from A to the side DC. This is the perpendicular. This is the height of this parallelogram ABCD. AP is the height of this parallelogram ABCD and CD is the base. And we can also suppose AB is the base because opposite sides of a parallelogram are equal. Next, this is also the height of this parallelogram CQ. CQ becomes also the height of parallelogram ABCD. This is the height of this parallelogram. Or we can also make the height of this parallelogram in this way. BR. BR is the height of triangle. BR is the height of parallelogram ABCD, because this BR is perpendicular from B to the side CD. So CD is the base and BR is height of parallelogram ABCD. It is the height. So area of a parallelogram A equals to base into height. Now in this parallelogram, its area equals to base. Base is DC into height, either AP or QC or BR. We can write any one, AP, base into height, in this way. Now next, 4 number, rhombus. Rhombus is also a parallelogram in which its all sides are equal. It is a parallelogram and its all sides are equal. This is a rhombus, A, B, C, D. Its all sides are equal. It is a parallelogram, so its opposite sides becomes parallel. Rhombus is a parallelogram having all sides equal. So area of a rhombus area of a rhombus A equals to base into height, because it is also a parallelogram. So base is BC. Here if we have drawn the perpendicular from A to BC, AP is the perpendicular, then BC becomes the base. So area of a rhombus A equals to base into height, base into height. It is a parallelogram, so its area is base into height. In this rhombus, area equals to base, BC is the base, and height is AP. So BC into AP. And we can also find the area of rhombus by using its diagonals. Suppose there is a rhombus PQRS and its diagonals are given. This is one diagonal. Suppose it is D1. It is the first diagonal, and next is D2. This is the second diagonal. Suppose the next diagonal by D2. D1 and D2. First diagonal and second diagonal. Then the area of this rhombus, area of a rhombus A equals to half D1 into D2, first diagonal into second diagonal. Area of a rhombus A equals to 1 by 2 D1 into D2. In this rhombus, its area equals to 1 by 2. First diagonal is PR and second diagonal is QS. This. Now next, 5 number, trapezium. Trapezium. Trapezium is a quadrilateral in which its one opposite sides are parallel. A quadrilateral in which one opposite sides are parallel is called trapezium. This quadrilateral is a trapezium because it has one opposite sides are parallel. AD and BC are parallel. So it is a trapezium. And area of a trapezium A equals to 1 by 2 into height. This is the height of this trapezium, this h, because AP is perpendicular from A to the side BC. This A is on this side AD, and AD and BC are the parallel lines. So AP becomes the height. This is the height, or this can be also the height of this trapezium. Let's say it is DQ. It is also the height. So area of a trapezium A equals to 1 by 2 height, 1 by 2 height into sum of parallel sides. Sum of parallel sides. Sum of parallel sides. 1 by 2 height is h, and if we suppose the parallel sides by A and B, these two sides A and B, then it becomes 1 by 2 h into A plus B. A and B are the parallel sides of this trapezium. Next, kite. Kite. It is a quadrilateral whose adjacent sides are equal. This is a kite. Its adjacent sides are equal. This side and these sides are equal, and this side and these sides are equal. A, B, C, D. This is a kite whose adjacent sides are equal. BC equals to DC and AB equals to AD. This is one diagonal. Suppose it is the first diagonal of this kite. D1, suppose it is D1, and suppose it is D2. First diagonal and second diagonal. It is the shorter diagonal and it is the longer diagonal. And area of a kite, kite A equals to 1 by 2 first diagonal D1 into second diagonal D2. 1 by 2 D1 into D2. Next is quadrilateral. Quadrilateral. Suppose it is a quadrilateral ABCD. In this quadrilateral, AC is a diagonal and BD is another diagonal. Oh, only AC is one diagonal, and on this diagonal, this BP is a perpendicular on the diagonal AC. And next, DQ. DQ is perpendicular on the diagonal AC. In this quadrilateral, AC is a diagonal, and on this diagonal, two perpendiculars are drawn from other two vertices, B and D. BP is one perpendicular drawn from the vertex D to the diagonal AC, and DQ is another perpendicular drawn from the vertex D to the diagonal AC. Suppose it is first perpendicular P1 and it is the second perpendicular P2. Then the area of this quadrilateral, area of a quadrilateral A equals to 1 by 2 diagonal into sum of perpendiculars drawn from other two vertices to the diagonal. It means P1 plus P2. 1 by 2 diagonal into sum of the perpendiculars drawn on this diagonal. Now the students, now I will start the theorem 1. Theorem 1. The statement of the theorem 1 says that the parallelograms on the same base and between the same parallels are equal in area. This, it is the statement of the theorem. The parallelograms on the same base and between the same parallels are equal in area. What does this statement says? Look, parallelograms on the same base and between the same parallels. There are the parallelograms on the same base and between the same parallels. Suppose this parallelogram and this parallelogram. There are the two parallelograms. There are the two parallelograms on the same base CD. This parallelogram ACDE and the parallelogram FCDB are standing on the same base CD and between the same parallel lines AB and CD. These two parallelograms are standing on the same base. They are made on the same base CD. This parallelogram is standing on the base CD, and this parallelogram is also stands on CD. Both parallelograms are standing on the base CD. They are formed on the same base CD, and between the same parallel lines AB and CD. In this case, the area of parallelogram ACDE equals to the area of parallelogram FCDB. Their areas are equal. The area of the parallelograms which are standing on the same base and between the same parallel lines are equal in area. The area of the parallelograms are equal if they are standing on the same base and between the same parallel lines. If the area of this parallelogram ACDE is 15 cm square, then the area of parallelogram FCDB is also 15 cm square. Its area is also 15 cm square because they are standing on the same base CD and between the same parallel lines AB and CD. Now the students, if there are many parallelograms standing on the same base and between the same parallel lines, then their areas are also equal. Suppose this parallelogram and this parallelogram and suppose this parallelogram